Here we go. 1.3, solving equations with variables on both sides. Notes continued. These will be much shorter and much sweeter. How can you solve equations that have variables on both sides is our essential question. Okay, there's only 3 problems. Here we go. Number 1. Why did I do this one? Well, you have distribution on both sides too. Okay, so SIPSy again. So simplify. I've got 4 times whatever's inside parentheses stays inside. And then bring down the sign. And then 4 times whatever's inside parentheses stays inside. I know you think I'm doing too much, but trust me, I promise you, if you just do it this way, you will make fewer mistakes. 3 times whatever's inside parentheses stays inside. Bring down the sign. And then 3 times whatever's inside parentheses stays inside. Okay, so simplify. Remember, we've got distribution. We can combine like terms. We've got all sorts of choices. So this is going to give me 8x minus 12 equals 3x plus 30. Okay, once I get to variable plus a number equals variable plus a number, the only thing I do from that step is go big or go home. GBGH. So remember, you're going to point to this one, and you're going to point to this one, and you're going to say which one's bigger. Well, since the 8's bigger, I know I need to move that 3. In order to move it, I have to do inverse operations. So if I have positive 3 on the right, now I need to undo positive 3. So I have negative 3. So now I've got 5x minus 12 equals, these are opposites, 3. Now I can go to my identify stage. So I've got do and undo. Oops, that's an I, sorry. Okay. Do and undo. So I look at the side just with the variables, or variable, excuse me. And the symbol out in front of this number is a positive. The symbol out in front of this number is a negative. So what's going on between 5 and x? I have multiply by 5. How do we undo multiply by 5? Divide by 5. Then I've got subtract 12. So I add 12. This is my SADMEEP. So I know I'm going to do add and then divide. So I'm going to add 12 to both sides. Both sides. These guys are opposites. This gives me 15. Check mark. Then I'm going to divide both sides by 5. Any number divided by itself gives me a 1. And 15 divided by 5 is 3. Oh, that was my perform step, sorry. And then final step, check step. And I always have to go back to the original equation. So I've got 4 times 2 times, I think x is 3, minus 3, question mark equals, remember, we just built a fence. You can no longer go from side to side because you built the fence. Again, replace the x with a 3, plus 1. So now we're back to PEMDAS. Okay, 2 times 3 is 6. 6 minus 3 is 3. There's my 2 steps. 3 plus 1 is 4. 4 times 3 is 3. And then I get 12 equals 12. Check and box. Okay, 2 more. Now, these are what's called special solutions. And you're going to see why in just a second. Remember, nothing changes. You still have to do the simplify step. You still have to do go big or go home before you do anything else. Okay, that being said, here we go. We look at our variables and we say, oh look, I have negative 4x and negative 4x, and all of a sudden you have alarm bells going off in your brain. No worries. We're still going to do exactly what we've been doing. Go big or go home. So my first step, I'm going to rewrite the problem just so you can watch it. Negative 7 minus 4x. So go big or go home says I need to move this to the left. Why am I moving to the left? Because you want the variable on the left anyway. Opposite of negative 4x is positive 4x. Yep, wonky butt. There you go. These guys cancel. So I have 3 equals negative 7. Nope, that's absolutely not possible. The answer to this one is no solution. Now, back up just a second and I'll show you. What this means is that there is no number I can plug in for this x to have these two sides be equal. I will never be able to multiply negative 4 times a number and add 3, and negative 4 times a number and then subtract 7 and get the same number in the end. So that's why there's no solution. There is no chance you can do this. Okay, one more. So first step, we've still got to simplify. So we've got 3x plus 15 equals 3 times whatever's inside parentheses stays inside. Bring down the sign. And then 3 times whatever's inside parentheses stays inside. So I've got 3x plus 15 equals 3x plus 15. Okay, next step, go big or go home. We're still on the simplify stage. So we look at our 3x and we look at our 3x and go, oh my goodness, we have the same thing. We still have to get rid of the variables first. You cannot skip this step. So 3 minus 3 gives me 0. 3 minus 3 gives me 0, and I end up with 15 equals 15. Now, this one up here on number 5, 3 was never going to equal negative 7. However, 15 always equals 15. So this one means you can plug in any number you want, and you will always have an equation that's true. So in this one, it's infinite solutions. So it doesn't matter what you plug in. If you plug in 9, you'll get 60 on both sides. If you plug in 1, you'll get 18 on both sides. Whereas if you try that up above on number 5, it will never work. Okay, those are your special solutions. The clue that you're looking for is when you have the same number and the same number in front of the variables and then plus something and plus something. You're always going to end up with a special solution. Either everything will work or nothing will work. Okay, good job, guys.